Hi, this is Andrew with Front Range CNC. Today's video, we want to talk about some of the things to consider when a CNC is being built and how that impacts the long-term life of the CNC, but also the overall cut quality of that machine. On industrial sizes, 4x8, 5x10, 5x12 even, there really is a pretty sweet spot when it comes to the mass of the machine, and that then gets bundled with your horsepower of spindle and so on. But that machine mass is going to help with a tremendous amount of potential vibration being introduced. And you see this on most machines that are 4x8, even 5x10s for the most part are in a pretty similar weight range, from 60 to 80,000 or so. And you really want to aim for no less than 4,000 or 5,000 pounds. I would say 4,000 is even maybe on the low side of things. The steel, not only in the frame but in the bridge and on the uprights as well, directly translates into how well you're able to cut everything from plywood to MDF to hardwood to aluminum and plastic, and makes a really large difference. A lot of times, if it's a bigger difference you would ever guess, even just the same spindle on a machine that weighs 2,000 pounds versus 5,000. It's very different. But with that, obviously a cost would go up because now you need larger motors. And so, on our Y-axis, we've got 750 watt motors on the Y, the X, and the Z as well. And so we try to make sure that everything we're using is sized correctly for the weight of the machine. Our 5x10 is closer to 5,500 pounds. Our 4x8 is closer to 5,000 pounds. And that just makes a huge difference in overall cut quality versus having to use a machine that's maybe part steel, part aluminum, etc. But if you do need to save some on cost, that would be an area where if you did get a slightly less sturdy base, you can still cut plywood and MDF and so on, but you'll need to do so at a much conservative amount, whether it's depth of cut or even just speed of the machine moving through the material. That would impact that directly. The other thing you'll run into in terms of the mass of the machine is how that frame is made. And typically on the industrial style machines, there's the same process is followed for almost all industrial style CNCs, in that the frame is welded, stress relieved, and then from there it gets placed on a larger mill style machine that is going to more or less flatten everything. So a lot of times this will be the top surface as well as the sides. And the sides are done because that's where your rails are going to be mounted. And so those surfaces need to be as parallel and as flat as you can possibly get. The rest of the frame normally then is not milled in that sense. So before everything goes to paint, typically that's what you're seeing on nearly every industrial size machine. In fact, I can't think of a single one over 60,000 or so that's not done in this style. And that adds to the overall accuracy of the frame, but it doesn't necessarily translate into the accuracy of the machine. There still is another component that gets done after that machine is then assembled. So, let's say your machine has been welded. It's now been planed flat, and on the sides where the rails are, it's now gone to paint. It's now in assembly, and the rails are mounted. The rack and pinion or the ball screw is now secured and mounted. The bridge is put on, and everything is now working, so to say, and it's square and everything's good. And the next step that has to be done is there has to be some degree of a compensation table that is input based on not only the size of the machine, but what kind of system it's using, a ball screw or a rack and pinion. Typically on these size of machines, you'll see it done every 2 to 5 inches. And so what will happen during that quality check process is that machine will be told in the control software to move 2 inches, and then the physical distance is then measured. And so from there, you are then able to determine how accurate the frame is to the controller. Normally, you'd still see a few thousandths degree of variation, even on a really, really dialed in frame. And that's okay, because on the industrial size controllers, the Fagor, the Fanuc, the Syntec, all the controllers we offer are all industrial and all have got ability for compensation tables. You then are going to input those values. And so if your machine was physically off by 2 thousandths, think a couple human hairs, then that is actually input based on that laser. So it's more than just saying, is everything square? It's actually taking out those physical imperfections of your ball screw, or your rack and pinion, or even just how your rail is just slightly spaced out. And the controller is then saying, every spot on the table, I need to make an adjustment based on that unique location. And that is how you get a really accurate machine for a long time. And these tables can be updated over time, as you experience wear and so on. And so, the benefit of having a really sturdy frame paired with, an industrial style controller, gives you a lot of control over that machine, for the life of that machine. And it really makes a huge difference, as you start cutting more and more and ramping into production. And even just as components get older, you can keep everything running really well, versus having to just replace things because maybe they've mechanically, are starting to wear. If you do have any questions about the frame process and how the frame is made, and just in general, how it impacts what you're doing, feel free to give us a call or write us an email and reach out, and we'll be happy to talk with you about just CNC router frames in general, and how it translates, and that overall quality process of how you get, the end result to be highly accurate for a long period of time. Thank you.